Hello guys, welcome back to my channel. In this particular tutorial, I'm going to take you through the binary arithmetics. We need to remember that a computer processes data by performing either of the following arithmetic operation, that is addition, subtraction, division, and multiplication. For subtraction, it is carried out through complementation, while for the division and multiplication, we go for the shifting method. For this specific video, I'm going to show you on how to add the binaries and also on how to subtract. Okay, these are the possible basic arithmetic addition for all the binary numbers. For example, if you take 0 and you add to another 0, it should give you 0. While when you take 1 plus 0, it always gives you 1. 0 plus 1 is equal to 1, while 1 plus 1 is equal to 1, 0. But for the case of where we have 3 characters, for example, 1 plus 1 plus 1, it should give you 1, 1. But for the case of 1 plus 0 plus 0, it will give you 1, 0. Just like this one, and this other one, these are similar. Only that we have additional zeros in between. But as we go through the example that we have, you'll be able to note some of the examples of that nature that we have. Okay, having done this, these are the most important part on the binary addition. As long as you are able to interpret each and every possible basic arithmetic addition, you'll be able to get the working correct. Okay, let's go to the examples that we have. For example, our example number 1, we have 0, 1 base 2 plus 1, 1 base 2. So you add this binary to this other one. And also guys, if you are new to my channels, don't forget to subscribe. Support me by subscribing to my channel so that you can have more numbers, as well as continue sharing this particular video to your friends who are experiencing the same problem. Okay, let's dive to our example number 1, where we have 0, 1 plus this one. So remember, let me create two scripts so that you can have we can compare. Okay, let me try to minimize these. Okay, so these are the rules. We have the rules on this side, and we have now the working on the other side. Okay, remember, we have 0, 1 plus 1, 1. Then you had, remember the rule number this one. Whenever you had 1 plus another 1, it should give you 1, 0. And remember, it is not 10 but 1, 0. Remember, we are working with binaries, not the normal numbers. Now we have 0 there, then you carry 1 above, so we have the 1. Now we have 1 plus 0 plus 1, which takes us to this the last rule, which is 1 plus 0 plus 1, which is equal to 1, 0. Therefore, you write this as 1, 0. So my final answer for this one, therefore, the answer is 0, 1, 0, 0 base 2. So it is that simple. I hope you have understood on how to go about this one. Okay, let's go to another example. So for this one, 0, 1 plus 1, 1, it should give you 1, 0, 0 base 2 as the answer. Okay, let's move to another case where we have 0, 1, 1, 0, 1 plus 1, 1. So for this one, we have 1, 1, 0, 1 plus 1, 1, 1 over plus. Remember the rules again. Whenever we have 1 and 1, you get, I hope you have seen that, you get 1, 0. Therefore, you write 0. Then you carry 1 there. Then we have this other rule. Whenever you have 1 plus 0 plus 1, it should give you 1 0. Therefore you write the 0 there, then you carry the 1 above, then 1 plus 1 plus 1, 1 plus 1 plus 1, this 1 plus 1 plus 1, it should give you 1. Then just like this one, it should give you 1 1. Therefore you write the 1 of the 1, then you carry the other one to the other side, to the left hand side, then 1 plus 1 should give you 1 0. Therefore my answer for this one is 0 1 0 1 0 0 base 2 is my answer. I hope you have understood on how to go about this one. As long as you are able to interpret what we have on this side, this one, the rest of the working will be quite easy for you. Okay, let's have another last example on addition. On addition, we have this one where we have 100 plus 1001. Okay, I will give you maybe a minute for you to do this, then we'll do it as a group. Just take 1 minute. 1 minute is enough for this one. Okay, now I hope you have gotten the answer. Okay, for this one we have 1 0 0 1 0 1. Then we had, remember the rules, 1 0 1, this one, it should give you 1, while for the 0 plus 0 it should give you 0. Then for 1 plus 1 it should give you this other one, which is a 1 0. So what we have applied, we applied 0 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 1 is equal to 1 0. So my answer, the answer is supposed to be 1 0 0 1 base 2. This is the final answer. I know most of the students get a lot of problems, especially those who are taking maybe computer science on how to add the binaries. But as long as you are able to interpret these rules, the basic possible basic arithmetic that we have, you will be able now to get everything correct. Okay, having done that, let's move now to the next part. I hope you have understood on how to go about with all the additions. And remember guys, if you're still new on this channel, don't forget to subscribe and also to like my video. And also, in case you have any question that is disturbing you related to binary addition and binary subtraction, don't forget to write it on the comment section. I will get back to you as soon as I see your question. Okay, let's move to the next part. I hope you have understood on how to go about with this one, the binary additions. Okay, let's move to binary subtractions. And for the binary subtraction, we use 3 ways on how to get 3 ways. That is 1 complements, 2 complements, and direct subtractions. So we have the binary, the 1 complements, these are the steps, 2 complements, the steps, and lastly the direct subtractions. Okay, for the case of, we will start with the first case whereby we will simplify our equation using the 1 complement. For the 1 complement, these are the steps that you are supposed to follow. Number 1, you need to ensure that both numbers have the same number of bits by adding zeros to the left hand side with fewer bits. Then step 2, you need to generate a 1 complement of the negative number. And number 3, you need to add the generated value to the positive number. You add to the generated value Then lastly, if the answer obtained has more bits than the original bits, that bit is what is referred to as the overflow. So what you are supposed to do, on that, you take it and add it to the least significant bits. Then remember, if the answer obtained has the same number as the original number, you adapt that as the answer. But let's do it as an example. Maybe it will make more sense when you are doing it as an example. Okay, let's go to it. Okay, let me try to minimize the rules. Okay, so here goes my first example where we have okay, let me try to minimize. Remember the rule number one. If ensure that both numbers have the same number of bits by adding zeros. If you look at my case, the number of zeros are not equal. So what am I supposed to do? I will add 0 on this other scenario, this one. Okay, I will add 0 on this one. So what I will have 1, 1, 0, 1 base 2 minus 0, 0, 0. Sorry for that. Supposed to be 1, 1, 1. If we look at our scenario, we have equal number of bits of the two cases. Okay, after doing that, the next step as per our instructions or the steps that we have is to generate a one complement of the negative number. Remember, this is my negative number. This is my negative number. Therefore, for me to get one complement, what am I supposed to do? You are supposed to convert the zeros to 1 and ones to zeros. So the complement for this one will be, this is a 0, 1, 1. So the complement will be 1, 0, 0, 0. That's the one complement. After doing that, the next step is to add. You add the written value to the positive. Okay, so after that, I will need now to add the two numbers. So what I have 1, 1, 0, 1. Then we have 1, 0, 0, 0. Then we have the two cases. Remember the rules of addition. 1 plus 0, it should give you 1, while 0 plus 0 is equal to 0. 1 plus 0 is equal to 1, but 1 plus 1 is equal to 1, 1, 0. Remember, if you look at the rule number 4, if the answer obtained has more bits than the original number, which is very true, the original number has 4 bits, but for this case, it has more. The number of bits that we have 5 bits. So what are we supposed to do? Now, for this other case, I will try to highlight. So this is what we refer to as the overflow. This is my this is the overflow. An overflow. So how do I go with the overflow? Okay, I will try to so that's the end of the first part. Okay, so what I will need to do on the overflow, I will take 0, 1, 0, 1. Then I will add to the overflow, which is 1. So the final answer will be 0, 1. Then this is supposed to be 1, 0. Therefore, my final answer for this question is supposed to be, the answer is 0, 1, 1, 0 is my answer. So this is the final answer. I hope you have understood on how to go about it. Okay, let's go and do another example, still on this case. So our next example, we have this one. So we have 1 0 1 0 base 2 minus 1 1 1. So as you can see, both sides have equal number of bits, so there is no room for addition of an extra bits. So what I will do, I will just move directly and get a 1 complement of this number. So a 1 complement of this one will be 0 0 0 0. Remember, 1 becomes 0 while 0 becomes 1 for a 1 complement. Okay, now having done that, the next step is to add both sides, the two positive numbers. So what I will have for the other side, I will have 1 0 1 0 plus 0 0 0 0, and I will get eventually the answer will be 0 1 0. This is a straight case, it's not complicated. Therefore the final answer for this one is 1 0 1 0 base 2. That's the answer for that. Okay, having done that, the next step is to go to the next case. In our next case, we are supposed to have a two complements. Okay, let me try to. For two complements, these are the steps that we take. Number one, you need to ensure that both numbers have the same number of bits. Then you generate one complement for the negative number. Then you add. Then if you look at number 5, add. For number 4, you add 1 to the generated value to get two complements. This is very important. What you need to note is this one. After you generate the number, you need to add 1. Then number 5, you need to add the two complements. If the answer is obtained is more than the original, the extra bit, which is also of course known as the overflow, is excluded from the answer. Okay, let's go directly to the examples that we have. Let me try to minimize this one. Then we have this case. Okay, let me start with the I will just use the same example that we had, that is a 1 1 0 1 minus 1 1 1. I think this seems too small. I think it's better. Okay, let me try to do this so that you can able to see what I'm doing. Then for this one, I will try to minimize it. Okay, let me try to move it from this other side. So remember the rules. If the number of bits are less, you add. So what I will need to do for this one, I will need to come up with, so for this one it will be 0 0 0, sorry, suppose be 0 1 1 1, so that we have equal number of bits. Okay, after that you convert the negative number into a 1 complement. Now for you to convert the number, you convert to 1, so the number will be 1 0 0 0. Okay, after that the next step is to add. Okay, let me try to create a number. You will add the answer that you have gotten from the one complement. You had 1, therefore we'll have 1 0 0 0, then you had 1. So what I will get eventually, I will get this is a 1, this is 1, this is 1 0 0 1. So this is the answer that you get after you add the 1, so that your number is now as 2 complements. Okay, after getting that, the next step is to work on addition of the two numbers. And the first number that we have 1 1 0 1 plus 1 0 0 1. So I will get 1 plus 1, you get 1 carry 1. 1 plus 0, you get 1. Then 1 plus 1, you get 1. Then 1 plus 1, you get 0, 1. So the answer that you get after you add the two numbers is 1, 0, 1, 1, 0. Now remember the rules. If there is an extra bit, they are more than the original number, you exclude this principal number 5. You exclude it. So the final answer will be, for my case, the answer will be 0, 1, 1, 0. Base 2 is my answer. Okay, having done that, I hope you have understood on how to go about it. If you still have challenges on how to do the subtraction, you need to go through this particular step that I've highlighted. Okay, let's move to another example where we have 1, 0, 1, 0 base 2 minus 1, 1, 1. So I'll give you maybe a minute to go through the whole thing. You can do maybe the equation, then as we do, you can as well as try to make the correction. Just follow the instruction, or rather the steps that we have written them down. If ensure that both numbers they have the equal number of bits, then you generate one complement. Then you add one value to the generated so that you get a two complement. After that, you add both the numbers. Okay, let's do it now. So step number 1, since the number of bits are equal on both sides, I will go directly to conversion to generate a one complement. So a one complement of this one will be 0, 0, 0, 0. Then after that, you need to remember, after you get now the one complement, you need to add 1 so that the number generated is now a two complement. Therefore, we'll have 0, 0, 0, 0 plus 1, which is a 1, 0, 0, 0. Therefore, after getting that, the next step is to add the two numbers. That is a 1, 0, 1, 0. Then you add 2, 0, 0, 0, 1. So what we'll get eventually is that you'll get this one plus this one, you get 0 plus 1, you get 1. 1 plus 0, you get 1. 0 plus 0, you get 0. 1 plus 0, you get 1. Therefore, the answer for this case is 1, 0, 1, 1. Therefore, the answer for this one is 1, 0, 1, 1 base 2 is the answer. I hope you have understood on how to subtract two numbers following, or rather going for the two complements. Okay, having done that, let's move now to our last case, that is a direct subtraction. And for the case of direct subtraction, these are the neat things that you need to note. These are the possible basic arithmetic addition in a direct case. 0 plus 0 is equal to 0, 1 plus this one, just like we had done on the previous case. This one is usually a direct case. So usually a direct case. So 0 minus 0 is equal to 0, 1 minus 0 is equal to 1, 1 minus 1 is equal to 0. Okay, let's go now to our examples, because examples will make my work easy as well as serious. Okay, so what we have, the first example, we have 1101 and 111. So step number 1, you need to ensure that both sides they have an equal number of bits. So I will have an equal number of bits. Therefore, what I will have 1, 1, 0, 1 minus 0, 1, 1, 1. Okay, having done that, the next step is now to subtract the two sides. So we have 1, 1, 0, 1 minus 0, 1, 1, 1. Then you subtract 1 minus 1, just like a normal mathematics. 1 minus 1 is always 0. While 0 minus 1, it's impossible. So what are you supposed to do? You borrow 1 from the left hand side. So you borrow 1 from this side and this remain with the 0. So this will be 1, 0. Now 1, 0. 1, 0 minus 1 is equal to 1. 1, 0 minus 1 is equal to 1. Now we had already left 0 on the other side. So you borrow this 1 from this side. So this is 10. So 1, 0 minus 1 is also 1. Therefore, this remains as 0. 0 minus 0 is equal to 0. Therefore, the final answer for my case will be 0, 1, 1, 0. That's the principle that we use. So this is the final answer. Okay, maybe I need to add something here so that we don't get confused. So we have 1, 0 minus 1 is equal to 1. So you need to know that principle. Okay, let's move to our last number. That is 1, 0, 1, 0 minus 1, 1, 1. Maybe I'll give you maybe just a minute, then you do the whole thing following the possible basic arithmetic subtraction that I've highlighted on the left hand side, which is 1 minus 0, 1 minus 0 is equal to 1, 1 minus 1 is equal to 0, 1, 0 minus 1 is equal to 1. So as long as you are able to remember all these, you'll be able now to do all the subtraction that exists following the direct subtractions. Okay, let's go to the whole thing now. So what I have 1, 0, 1, 0, then 1, 1, 1. So what I will do, I will so we have 1, 1, 0, 1, 0. Therefore, minus 1, 1, 1, 1. Okay, this one will have some problem because the value that we have at the top is larger than the problem that we have on the bottom. So let me change this one. Allow me to change this one. So we can convert to a number like maybe a number like this one. And the other number, we can have a number like that. So we can try to do this one. So this is a 0, 0, 0, 1, 1. Then the other number is 0, 0, 0, 0, 1. Then you subtract directly. So what we have 1 minus 1, just as we have on this other side, is always 0. Well, 1 minus 0 is 1. While 0 minus 0 is 0, 0 minus 0 is also 0. Therefore, the final answer for my case is supposed to be 0, 0, 1, 0, base 2 is the answer. This is my answer. So it is that simple for binary addition, binary subtraction, following either the complement 1, complement 2, and the direct subtraction. So I hope that you have learned something through this particular video. So for you guys to support me, kindly subscribe. If you have any question, just write it on the comment section. I will get back to you as soon as I get to see your question. And also share the work with your friends so that they can also learn on how to work on the binaries. Thank you and have a lovely day. Bye bye.